We are live, sir.
Okay, thanks. Hi guys, good evening. I hope you all are ready and all excited for today's session. So in the last session, we had some great things to discuss, and yes, I think we all of us enjoyed that session. So I think the last thing what I discussed was a bit of this array thing, right? Something about array I discussed. So yeah, this class I'm taking this session forward to about this array and linked list. So I hope you all would be ready. But before I get into this thing, I think you might already understand this linked list thing would need the knowledge of dynamic memory allocation. So what I'll do is I would start with this dynamic memory allocation. Actually, I'll give you a brief idea about what this dynamic memory allocation all about, and then we can actually easily get into this array and linked list. Okay, just give me a moment and I'll share a screen and we can start it off. Okay, just give me a moment. Yeah, so guys, yeah. So who can say like what is this dynamic memory allocation? So we have the static memory allocation and dynamic memory allocation, right? Yeah, hello, Subham. So tell me, guys. So what do you know about this dynamic memory allocation? We have static memory allocation, we have dynamic memory allocation. So what is like the difference between these two things, dynamic memory allocation and static memory allocation? Can anyone say me? Yeah, we are learning array and linked list today. So before that, I am just giving a brief idea about dynamic memory allocation because we would need that, right? So yeah, Harshit, you are saying allocating memory at runtime. Yes, you are correct. So allocating memory at runtime is known as dynamic memory allocation, right? And can you give me an example where we use the static memory allocation and where we use this dynamic memory allocation? Can you give one example where we use it to implement some concept or something? Just give me an example where we use it. Give me one example of two data structure or like one data structure where we use static memory allocation and one data structure where we use this dynamic memory allocation. Yeah, linked list is dynamic memory allocation. Like linked list, in linked list we use dynamic memory allocation, and in this array we use static memory allocation. So array is static and linked list is dynamic. So this we understand, right? So please make this thing clear. Right. Okay. So please make this thing clear that we have this linked list which uses dynamic memory allocation, and we have this uh, array which uses static memory allocation. So what is the difference? Why we go for this dynamic memory allocation actually? What is this term dynamic? What do we mean by it? The thing is, see, array when we create an array, so we have to give some size, right? Let me share this with you. Just a moment, guys. I'm just sharing a screen with you so that I can scribble something there. Yeah, I hope it's visible to you. I have shared the whiteboard. Yeah, it's visible now. Yeah. So when we declare an array, when we create an array in C, so we write int, let's say ARR, and we have to mention the size. So this would actually allocate a size of 10 blocks. Like we can store 10 elements here. Index would start from 0 and the last element index would be 9, right? So this size is fixed. I cannot change it. So we say array cannot gain weight or it cannot be on diet. So it is fixed, it is static. Once we create, the size is fixed. It's not very flexible. Whereas in linked list, it uses dynamic memory allocation. So whenever we need one more element, one more value to store, we can easily create memory dynamically, and that would do the thing. Right. Okay. So that's what is all about, guys. So this array and linked list comparison, and what is this? Why we go for this linked list? Actually, that's what I was discussing. Okay. So let's get into this dynamic thing a bit more. So there are certain functions there to dynamically allocate memory. You might have heard about this malloc or malloc, memory alloc. Then we have the calloc, okay, contiguous allocation, and this is memory allocation. We also have realloc, okay. Then we have something called free. So these are the functions which are involved in this dynamic memory allocation, okay. So this malloc alloc, these are used to allocate new memory dynamically. This realloc is used to reallocate the already allocated memory. Let's say you have allocated 5 bytes. Now you want to increase the size of the memory or decrease the size of the memory. Then you will go for this realloc. Okay, right? And what is this free? Free is used to deallocate. If you allocate something, if you want to deallocate it, then we'll be using this free. Okay, we don't like do this thing in static memory allocation. I'll talk about that a bit. Okay, so here I need to give you some idea about this memory area, guys. Okay, there are different memory area, but I just would take this two memory area. One is this stack memory area, okay, and one is this heap memory area. So all those local variables which we create, what are local variables again? If let's say I have a function, and within that scope of the function, if I create a variable, so this variable x is a local variable. So all these local variables which are declared inside a block, within a block, those variables are actually created, like, or memory for those variables are created in this stack memory area. Okay, so you can say all the static memory allocation are done in this stack memory area, whereas all the dynamically allocated memory is done in this heap memory area. Okay, so dynamic memory allocation is done from heap, and static memory allocation is done from stack. So the stack memory area, this is not the data structure I'm talking about. This is the stack memory area. Okay, there are certain memory areas. So among them, the stack and heap memory area are there. In stack, we store these local variables, and in heap, this dynamic. It is maybe you can say it is designated for this dynamic memory allocation thing. Okay, fine. Okay. Let me clear out these functions. So you can either use calloc or malloc, but normally malloc is preferred actually, guys, over calloc, because malloc is faster than calloc. So the difference between malloc and calloc is, in malloc it would allocate a memory, okay, and it would return the address of the memory. Let's say address is 101, so it would return this 101. Calloc, whereas it will allocate the memory, okay, it would initialize with 0. It will allocate the memory, it will initialize it with 0, and then return the address. So basically same thing, only difference is this calloc will initialize the memory with this default initial value 0, whereas malloc will not initialize anything, so some garbage value would be there initially. Okay, but anyway, we don't want a memory where normally we don't need that actually to have some initial value in the memory. So pretty good, malloc, using malloc is pretty good. Also it is faster than calloc or calloc, so we go for this malloc or malloc. Okay, so I would be using this malloc actually, and both malloc and calloc you can use actually to allocate contiguous memory allocation, but calloc normally, yeah, we can use both things. So I would prefer malloc as it is faster compared to the calloc. So I want to dynamically allocate a memory for storing one integer, guys. So that's where we also need pointer. Okay, so this pointer and the dynamic memory allocation thing works together actually. Through pointer, we can actually allocate memory, because what I said, this malloc or calloc, it would allocate the memory at runtime and it would return the address of that memory, right? So that address need to be kept somewhere, And where is that somewhere? Pointer, because pointer can hold address. So I would create here a pointer to integer in star p, because yes, p is a pointer to integer. Okay, I want to store integer. I want to create a memory for integer value. Then I can write p equal to in star. I have to typecast it into in star malloc size of, I want how many byte? Okay, size of one int, because I want to store one integer value. So I need to mention here what amount of memory you want to allocate. So this would be the syntax to create memory, guys. This malloc will allocate a memory in the heap memory pool for one integer. So it will have some address, and this would return the address to p. So what is this p? P is a normal variable. So this is done in heap memory area, and in stack memory area, this memory for p is like created. Okay, is allocated. It will have some address. Now whatever malloc returns, so it would return the address of the memory allocated. So that would be stored here, and we say that p is now pointing to the memory location. So we have this p, which is the only reference to the memory allocated dynamically. Okay, right? So this is what happens inside when you write this malloc and all. So in the memory area, in heap memory area, one memory is allocated dynamically at runtime. So at compile time, memory for p is created in stack memory area, because it is a local variable again. And when this statement is executed at runtime, one memory would be allocated in heap memory area, and address of that would be stored in p. So we say p is pointing to that heap. Okay, so what we write, so p is a pointer, and we have to typecast into pointer to integer type. Okay, and this malloc size of, like how many byte I want to allocate. You can just mention here 4 byte, but I just will mention like size of int. Whatever system you are using, it would calculate automatically the size of int, and that many bytes it would allocate. Okay, if you want to allocate memory for one structure, so I would mention here size of that structure, kind of that. Okay, clear, guys? Got this? This is the syntax where p is a pointer, and this is nothing but typecasting. We are typecasting the malloc. Why we are typecasting is malloc, the return type of malloc and calloc is actually void star, or you may call malloc and calloc. Okay, return type of malloc and calloc is void star. We need to typecast it into int star, pointer to integer, because we are allocating memory for integer. Okay, right? So this void star is called as actually generic pointer, guys. Okay, this is generic pointer. So what is this generic pointer? Generic pointer, it can actually you can say, what can I say? It can hold address of any kind of variable. Like you can store address of integer, you can store address of character, you can store address of this float, anything, because it is generic pointer. Okay, but the thing is, while access, like if you want to print the value, if you want to access the value through this pointer, then you need to have some typecasting thing. Okay, it is like you are specifying now particular the limit of this, or particularly you're saying, okay, now it is integer. Okay, the value stored is integer. Unless you typecast it, you cannot say, okay, what type of value you're pointing. So that's why we need to typecast it into int star. One more point is this void star can be converted into any kind of pointer, guys. This is void kind of pointer, void star. You can convert it into int star, catch star, anything. So that's how, like, it makes very void star, this generic pointer, very elegant. Okay. This is your generic pointer actually, void pointer, also called a generic pointer. So this void, if you see in C, it has two meaning. One is nothing, one is anything. Nothing function returns nothing, it doesn't take any argument, so we put argument as void, we put return type as void. And one is everything. This is void star, can act as everything. Okay, like void star can handle any kind of pointer, like it can store address of any kind of variable, integer variable, character variable, somewhat. Also, you can convert this void star into any kind of pointer, like int star, cat star. You can typecast it, no issue at all. So you have to clearly specify, right, what kind of value you are pointing to. That's why we are here typecasting it into int star. Okay, right? So yeah, so this is the thing how you allocate memory, and this is what happens in the background in the memory thing, right? So based on this, I want to discuss something, guys. So let me clear this thing. I hope you understood this part. See, if you don't typecast while printing, you'll get some like maybe you'll get some warning or error. Okay, you should typecast it. Yeah, you'll get some error when you print it because you are trying to print integer value, but it is not sure what kind of value it is actually pointing to. Okay, so you should actually typecast it. Okay, if you don't typecast, then it could give you error while printing because it doesn't know what kind of value exactly. It's like you can say. What can I say? Yeah, take this example. Like if you go on to buy some plot or something, so it is an open plot. You don't know like where is the end point and all. Now you you put a boundary. Now it is clearly defined. Okay, from this point to this point, the plot is there. Kind of that you can think of it. Okay, right? So let's see this. Yeah, I wanted to discuss this one. Stack memory area. In stack memory area, the local variables would be created. That is our pointer variable. I'll just put a star so that to denote it is a pointer. Okay, and this is heap memory area where the memory which has been allocated dynamically would be created. So let's say address of that memory is 101, address of this pointer p is 201, and as I said, malloc would return address of that allocated memory. So 101 would be stored here, and we say that p is basically pointing to it. Okay, so here I need to discuss something, guys. So let's say this is a scope, some functions. This is some function, whatever function, okay. And I have this like create. I had declared this pointer. I have created this pointer p equal to int star malloc size of one integer. So memory of one integer would be allocated, and address would be stored in p. So p is pointing, right? Okay. Right. Now, something you have done, some operation you have done, fine. So you are, let's say you have stored star p equal to 10. So 10 would be stored here. Star p is the value, like p is 101. Star p is value stored at 101. So basically you are storing 10 in the value of 101 location, right? So after doing some operation, now you are coming out of the scope of this block. Okay, so you're coming out, this block is over, function is over, all the statement inside this function is over, so you're coming out of the function. So what happens now? So I guess we all know this local variables are automatically uh, what is that, yeah, so this automatic variables or local variables would be deleted automatically when we come out of the scope of the block where it is created. So this p is actually deleted. There is no p in stack anymore. That means no one is now referring to this heap memory area. Okay, no one is now referring to heap memory area, right? Okay, so if no one is referring to heap memory area, now you cannot access that memory 101. Okay, so what happened here? So you have lost the only reference which you had to access this memory heap, this dynamic memory allocated. So this condition, guys, is known as memory leak. Sometimes in the interviews they ask, what is memory leak? This is memory leak. when you forget to deallocate this memory before going out of the scope of the block, you are losing the only reference to the memory. The memory would still be there. Actually, what happens, this dynamically allocated memory will not get deleted automatically. Only the local variables will get automatically deleted. Dynamically allocated memory will still be there holding some value, and you cannot access it anymore. Of course, yes, when your program is finished, this memory would be freed up. But the thing is, you are not out of the program. You are just out of the function scope. Let's say only this function fun scope. So P is deleted. This memory is still there. You cannot access it anymore. So it is known as memory leak. Okay, this is memory leak. So we should, as a user, we should be very responsible towards this. That is, before going out of the scope of this block, we should first deallocate this one. And how to deallocate? By using this free. We just write free P, and so this memory would be deallocated first. Then when you come out of the scope of the block, this P would be automatically deleted. So no memory leak. This is memory leak, guys. Okay, right? One more thing I want to discuss, that is, let's say, let me clear this thing. Yeah, this is stack where this pointer is there. Address is 201, and this is heap memory area where this what is this? Yeah, dynamically allocated memory, right? So some value is there 10, and we say P is pointing to this. Okay, fine. Now let's take a different scenario now. Okay, now I'll write here, I'm deallocating the dynamically allocated memory. So this has been deallocated. This is being this is freed up. Okay, this has been added to the free pool of heap memory area. Now, but P is still pointing to that address, because address is going nowhere, right? The memory is deallocated, freed up. It is not allocated for you now, but that memory is still there, right? The address is still there. Okay, P is still pointing to it. So this, what is this P? This pointer P now is called as dangling pointer. You might have heard this term. This is known as dangling pointer. Okay, right? This is known as dangling pointer. So previous concept was memory leak. When you forget to deallocate the memory, dynamically allocated memory before going out of the scope of the block, that is memory leak. And this is you deallocated memory, but pointer is still pointing to that address. Now let's say I'll try to print the data of star P. Okay, so this would give me some garbage value or something, because P is pointing to that address that may contain some garbage value. So this pointer, this pointer would be called as dangling pointer actually. Okay, if a pointer is still pointing to a memory location which has already been deallocated, that pointer is known as dangling pointer. This is more of a error situation, guys, you can say. Okay, that's we should not actually, after freeing up, we should not access that location, but you can, you should not. That's what I'm saying. So I hope this thing is very pretty much clear. This you need to be clear about this stack memory area, heap memory area, guys. Like pointer is created in stack memory area, but the dynamically allocated memory is created in heap memory area. This would be very helpful when you go for linked list program. You need to understand various things here. Okay, clear this thing, guys? This dynamic memory allocation thing, is it clear, guys? We can go to move to a quiz actually now. If it's clear, then we can move to quiz. Yeah, great then. So yeah, Kriti, can we move on to our quiz, first quiz?
Yes, sure, sir. Just a minute.
Okay.
I'll be
Yeah,
sharing
sure.
it.
Okay, okay, fine. Yeah, guys. So the link has been displayed. Can we like put this thing on full screen, Kriti?
Yeah, sure, sir. I'll also send the link in chat. Just a
Yes.
minute.
Sure. Thank you.
Thank you, sir.
Let me know, guys, when you are done with this quiz. We'll move forward to our discussion about this array and linked list. Yeah, lighting star, I mentioned, right? Memory leak happens when you forget to free it up. When you forget to use this free function. So just use free function before coming out of the scope of the block. Okay, where the pointer is defined. And dangling pointer, basically you don't have to access the memory location after freeing it up. That's all. Okay, you should not access it. Pranay, see stack. There are different memory areas actually. Okay, stack and heap memory area are one like they are a part of it. So the memory area is divided into different part. One is stack, heap. Then somewhere the instructions are stored. Somewhere this what is that? Yeah, data. Global variables are stored. Local variables are stored in stack. So kind of there are various memory areas. Yeah, guys, you focus on this quiz. You first carry on with this quiz and let me know. Then I'll continue. Yeah, Karthik, I'll surely summarize the thing. Okay, I see. I think most of you, like all of you, have done with the quiz, so I think we can continue. Yeah, great. Yeah, Sumit, great. Lavish, great. Okay. Fine. So yeah, I had said I would summarize thing. Yeah. So we discussed about this dynamic memory allocation, guys. So we had a comparison between this malloc and calloc, or malloc and calloc, and we would prefer malloc over calloc because malloc is faster compared to calloc. And a difference, if you ask me, one point is malloc is faster. CLOC will initialize, like allocate memory and will initialize with the value 0, which malloc doesn't do. We don't mostly we don't want that also, so we go for malloc. Okay, and then we talked about the stack memory area and the heap memory area. Okay, so all the local variables are allocated in or stored in stack memory area. All the memory which are dynamically allocated, those are allocated in heap memory area. Okay, so when we write int star p equal to malloc, like it is shown in the screen which I have shared, int star p equal to int star malloc size of int. So malloc will allocate a memory dynamically in the heap memory area, and the address would be stored in p. P is a pointer variable. Basically, it is a local variable. So p is in stack memory area, and the memory dynamically allocated memory in heap memory area. Okay. So I said if you are coming out of the scope of this function fun, which I have mentioned here, then P would be automatically deleted because it is local variable. So you don't have any reference to the dynamically allocated memory because dynamically allocated memory will not be deallocated automatically or will not be deleted automatically. You have to do it. You have created, you have to do it. Okay, so when you are coming out of the scope of the block, p is deleted, p is not there. You don't have any reference to the dynamically allocated memory. It is still there in the memory holding some value, but you cannot access it anymore. That situation is known as memory leak. To avoid this memory leak, what we have to do, we have to free that dynamically allocated memory before you come out of the scope of the block. Okay, right? So you free it up, then you come out of the scope of the block just by writing free p. I have mentioned there. This is how we avoid this memory leak thing. Then uh, the next thing is dangling pointer. What is dangling pointer? So let's say you have freed up the dynamically allocated memory, but this P would be still pointing to that address, right? Because address is not going anywhere, memory is also there, so that it would have some address. P would be storing 101, it would be pointing to location 101. So this P is now known as dangling pointer. Okay, if a pointer is pointing to a memory, dynamically allocated memory, which has already been deallocated, then that pointer would be called a dangling pointer. More of a, this is more of a error situation, guys. We should not access the location after deallocating it. That's all. Okay, so fine, then let's move on to our next thing, that is our array. I hope you all understood this dynamic memory allocation thing. So array, first of all, what is array, guys? Why we need array? So if you want to, let's say I want to store one integer value, so I'll create one variable, right? Integer variable, and then I want two values, so I'll create two variable. Let's say I want to create I want to store 10 integer values, so I would be creating 10 variables, 10 integer variables. Why to create 10 different variable with 10 different name, and maintaining those and remembering those name would be very hectic, right? It would be a like hectic job. Yeah. So what we do is, instead of that, we create array which can hold all those 10 variable, because all the variable are of same type. So array basically will hold same kind of value, same type of value. Okay, and it has only one name. So we should like we have to remember only one name. Through that one name we can access all the value. Yeah, of course, with some added feature we have to access. So array basically it is holding, or it will hold values of similar data types. Okay, it is a homogeneous collection of values, or you can say, sorry, it is a collection of homogeneous values, homogeneous type of values. Okay, and yes, the memory would be adjacent. So if I create int arr of 10, or let's say I'll just take an array of less size, yeah, int arr of 5. So in the memory, contiguous, like the adjacent 5 location would be allocated for you. 0, 1, 2, 3, and 4. Index would start from 0, and the last index would be n minus 1. What is n? If n is the size of the array, or the total number of element in the array, so index of last element would be n minus 1, because it starts from 0. Right? Okay. So how to access this each location? I think you already know it. So if I write arr of 0, it will access this one. Okay. If I write arr of 1, it will access here. Let's say if I write arr of 0 equal to 2, so 2 would be stored here. If I write arr of 1 equal to 5, so 5 would be stored here. Likewise. Okay, so we can access this location uh, through this index, or through this indices, you can say. So every location will have a respective index. First location is index 0. I can write arr of 0, then arr of 1, arr of 2, arr of 3, and arr of 4, the subscript thing. Okay, this substitute operator I'm using, and this 0, 1, these are indices. So this is what an array looks like, and this is how we go for. So basically, if I want to enter some values, so it would be very simple. I just have to run a loop. I equal to 0, I less than n, I plus plus. What is n? N is the size of the array, guys, total number of elements in the array. So obviously last index, or index of last element would be n minus 1. So that's why I have written less than n. So I can just take input for scanf percentile d arr of I. So I would be 0 when I is okay. Sorry, I missed out this one. Ampersand. When I is 0, value would be stored at AR of 0. When I is 1, value would be stored at AR of sorry, first value would be stored at AR of 0, then second value would be stored at AR of 1, then third value would be stored at AR of 2, and so on, right? So this is how we take input for an array, and printing is also simple. Just the same loop you write, print a percentile AR of I. That's all. So this is what basically like how we create array, how we take input to the array, and how we display the content of the array. Okay, so I think this is all fine, but let's see one thing. Let's talk about some address concept. And yes, one more thing, guys. I guess I had already mentioned that this array name is also like it behaves similar to a pointer, right? I think in the last session I had told you. If anyone has missed out, I'll just repeat that point. This ARR array name behaves actually as a pointer. How? Because this array name ARR actually holds address of the first element. Let's say address of first element is 101, then address of second element 105, 109, 113, 117, kind of this. Okay. So ARR will hold actually address 101, address of first element. So I say ARR is actually pointing to the first element. Right? 0, 1, 2, 3, 4. So ARR basically behaves as a pointer, which is holding this address of first element, and this address is known as base address. This is also address of the array. You can say base address is nothing but address of the array, starting address of the array. Okay, fine. So with this concept, what I would like to do is let's get into this address stuff, guys. More into this address stuff. If an array is given to us, let's say I've created an array, okay, of some size, let's say 50 or something. So it would be continued. Some elements are there. 2, 7, 9, 10, 8, 3, maybe, yeah, 0, 1, 2, 3, 4, 5. Okay, so here we just have some 6 elements. Address, I can just put some dummy addresses here. Let's say the first address or base address is 101. Of course, the second one would be 105 because each element will take 4 bytes. Then 109, 113, 117, 121. Okay, so 4 byte each, right? So that's how these elements are stored in the respective memory location. Okay, so and the name of the array is ARR. If I ask you what would be the address of this ARR of 3, ARR of 3, so by looking at here you can say, yeah, it's very nice, easy, 113, address is 113. Okay, fine, is 113. Address of ARR3 is nothing but 113. We can easily find out because we know the base address. Starting address is 101. So it is 105, 109, 113. We can calculate it directly because each element will take 4 bytes, right? What if our array is very large? Let's say I have created an array of 100 element and I'm asking you the address of the element located at 77th index. So it's not very feasible here to like draw that array and put the address of everything, right? So we need to understand we need to understand a mechanism through which we can find out the address of an element stored at any index. Okay, so based on this, this is what we are now going to discuss. So this is 5, let's say, and I need to find out the address of 5. Forget about the address whatever I mentioned, but yes, for finding address of any element, you need the base address of the array. Base address is given here, let's say 101. Base address you need it because if you don't know starting address of array, you cannot find the address of any element there. Okay. So yeah, so base address is given to you 101. So if I want address of this element located at index 5, so how basically I want to do, I would be finding it. So okay, base address is 101. because I would start from 101. Then I just need to check how many elements I have to cross or how many steps I have to take to reach that element. So I need to find address of this element, right? So how many steps? 1, 2, 3, 4, and 5. So I have to cover 5 elements here. Okay, so I have to cover 5 elements. So plus 5. Each element is taking 4 bytes. So total, starting from 101, I have to cover 20 more bytes, and the total is nothing but 121. So 121 should be address of ARR of 5, and yes, address of ARR of 5 is 121. Okay, right? Got it? So this is the way through which we can find out. So we can easily formulate like this one. We can convert this thing to into a formula. Like if I am asking you address of any element located at index I, address of ARR of I, if I am trying to find out, then it is nothing but this 101 is nothing but base address. This 5 is nothing but the same I. You see here. Here it was 5. Here it is 5 I, and this 4 is nothing but size of each element, so that I would call as W. So this thing would work fine with you to find out address of any element that is present at ith index. Okay guys, one second guys, one more point I want to mention here. uh, yeah, so here we know that the array index starts from 0. In an interview, maybe let's say the interviewer would be testing your knowledge or how much strong you are in the concept. He would ask, he or she would ask, assume that the array index starts from 1. Okay, instead of 0, let's assume that array index starts from 1. Let's assume theoretically. So now index 1, 2, 3, 4, 5, and 6, and I need address of ARR of 6 now. The same, basically the address of the same element, but now index is different, right? Even if the index is error of 6, but what would be the calculation? Calculation would be same, right? I'd start from base address. I have to cross 5 elements, and each element will take 4 bytes. So that would give me 121 address. Yes, 121. Fine. Now, if you would convert it into a formula, that is AR of I, that is this is base address plus. See, I is given as 6, but here we taken 5. We have taken 5. So it would be I minus 1 into W, size of each element. Why this 1 came? Because we assume that array index starts from 1. So looking at this, we are coming to a conclusion that okay, actually this thing is not a generic formula. Generic formula should be like this one. Address of ARR of I is nothing but base address plus I minus L into W. What is this L? L is the you can say lower limit of the index. If it starts from 0, you can put 0, L as 0. If it starts from 1, you will put L as 1. If it starts from 5, you will put L as 5. Likewise. Okay. So this is the way you can do, guys. So this would be your generic formula to find out the address of any element located at any index. So I'm giving you this thing in a way that you don't have to actually memorize things. Understand how I got to this formula. Then you don't have to mug up things. Okay, right? Okay. No, base address is same, Morris. Base address is same 101. We just assume that okay, index starts from 1. We are assuming that theoretically you have been asked that okay, assume that index starts at 1, not 0. Base address like it's same 101. So this is how you can go, guys, for this. Okay. So I hope you understood this point. If you understood this point, I would like to go on to the next thing, like the operation, some operation of array. Okay, fine. So I hope no doubt on this. Okay, sorry, I could not see some of the chat. We have asked. Are array elements immutable? Can they be overridden? Overriding thing is different, Sumit. Here, this overriding thing will not come. That is oops concept. So don't bring oops concept here. We are not discussing oops here. Array element immutable. No, array is basically immutable because we can change the value here. Okay. Anything else? Question I missed out? No. Okay, fine. Yeah, you would find it important, Sumit, when you get a question in any of the written round of campus recruitment drive. Some option would be given to you, and you have to find out. Okay, and yeah, so see this. And also, in if you go for 2D array, guys, there it some operation largely depends on how the elements are stored actually. So this address thing actually plays a role also. Okay. So yeah, so let's get into this operation of array. First thing I want to do is this insert operation, guys. Insert operation. So we will be discussing basically insert at end, insert at beginning, uh, insert maybe insert at middle you can do. So let's try to do this insert at this thing beginning and all. Yeah, but I would like to have the quiz, the one more quiz right now, and then we can actually get into this operation. So Kriti, can we have the quiz right now, the second one?
Sure.
Yeah, okay, thanks.
I'll be just a minute, guys. This is not the
Yeah,
one. Yeah, yeah. I'll put the second one over here. Yeah, this is the second quiz. I'll be sending the link in the chat also.
yeah, Manda, you guessed it right. Yeah, guys, please let me know when you are done with the quiz and all. Okay, so that I'll move on to the next thing. Okay, guys. So I see most of you are saying done. So I think everyone of you are done with the quiz thing. So we can continue with our discussion. I think. Okay. So let's discuss this insert operation of array. Basically, I'll be discussing this insert at end and beginning right now. Let's do it. Yeah, so if we have an array here, let's say we have some elements 5, 6, and 2, and 4, and maybe 9, and all, and there are some other memory like yeah, we'll be creating an array, let's say of size 30, and in that array, if we are storing values, like we have stored only this much value, we are yet to store some more values. Okay, right? So. So what basically like we have to do if we want to add a new element at the end. Okay. Now what is the value of n, guys? How many elements I have stored? 5 elements I have stored. So n value is 5, right? I want to insert a new element basically. Okay. So if I want to insert new element at the end, so what we have to do? It's very simple, right? I can just uh, Okay, so I can store AR at AR of n. I can store the new element. Let's say new element is x. For example, I have taken a variable x, and where I will be taking input for the new value. So I can directly write here AR of n equal to x, right? What is n? N is 5. So AR of 5. In AR of 5, this new value x would be stored. Let's say new value is 0. So 0 would be stored here. So is it done? Is it completed? Like have we done the operation for insert at end of the array? Okay, yeah, you can answer this question, guys. Is this operation done, completed, insert at end? Insert at end. Is this operation done? Like I had inserted this new element, let's say 0 at the end. So n is 5. So at AR of n, I stored this x. Okay, x is nothing but the new element which I had to store. So the operation is not completed yet, right? Why? The reason behind this is when you next try to print all the element, what is the loop? I equal to 0, I less than n, I plus plus. And we write printf percentile d arr of I. This is how we print all the element of the array, right? So I would start from 0 and it will go till n minus 1. N is 5. So you will just get up to this 5 to 9. You will not get this new element which you had inserted. The reason behind this is you have not incremented the size of n, the value of n. So you have to also increase the size of the array, right? Now it holds one more value. So we would increment this n. So don't forget about this. Forget this simple thing, a very tiny thing. Don't forget about this. Then include it. Then it will be fine. So it is pretty much clear now. We are done with insert at end. But the real task, it's very easy. But let's discuss about this insert at beginning, guys. Okay. So let me clear these things up entirely. Yeah, everything else may be there. Let it be there. I'll just okay. So I now want to insert a new element. Let's say x equal to 3, and I want to insert this at beginning. So maybe I want to insert it here. If I want to insert it here, then I need to make this place vacant. I need to make this place vacant, right? So should I directly store ARR of 0 equal to 3? No, right? If I do this, then this value would be replaced. This 5 would be replaced. I shouldn't be doing that. I don't want to lose any value. I just want to insert a new element at the beginning. So uh, uh, in that case, what we have to do then? Vinay, see, before increasing the value of n, you have to store the new value. Then you increase the value of n. That's what I said. Okay. Like first you would store the value at AR of n, then you increment n value. So in AR of 5, the new value would be stored, then n value would be incremented. This is about the insert at the end. Let's come to this one. So basically here we have to shift all the element, right? So 5 would be shifted here, 6 would be shifted here, 2 would be shifted here. So all the elements should be shifted towards right so that this place would be vacant. Like this would be 5, 6, 2, 4, 9. This place would be vacant. Now I can happily store this new element 3. This is what we have to do. So how exactly we would do this? How exactly we would do this? How we would shift all these elements? So tell me, guys, if I want to shift all these elements towards right, obviously I have to shift it towards right by one step. So what would be the loop condition? Like I would start from 0 to n minus 1, or I would start from this and come from right side. Just tell me that thing. From which direction, like in which direction I should proceed, from left to right or from right to left? Tell me. Just tell me this one, guys. Like how exactly to shift this? Begin with the last index. Harshit says begin with the last index. Shivam also says we have to come from right side. Yes, that's correct, guys. We have to come from right side. Why? Because if we go from left side, what would happen is, so now this is your array, right? 5, 6, 2, 4, and 9. So if you go from left side, first you will shift 5. So this 6 would be over written with 5, right? Then when you shift 5 again, this 2 would be again stored 5. So this is not the correct way to shift. Actually, what we should do is we should be coming from right side. Okay, like first we need to shift this 9, so 9 would come here. Then 4 need to shift it here, so this 9 would be replaced by 4. Then 2 would be shifted here, so this 4 would be shifted like replaced with 2. Then 6 would be shifted, so this 2 would be replaced with 6. Then this 5 would be shifted towards here. Basically we are copying to the next location, so this 6 would be replaced by 5. Now this location contains 5. So this is basically a duplicate value of 5 of the previous thing. So you can say it is backend. Now you can happily store here 3. So your array, like in your array, you have inserted a new element at the beginning, guys, right? Okay, so the loop here would start from n minus 1, and you would write I greater than equal to 0, I minus minus, because we have to decrement. Start from n minus 1, come to 0, decrement. So how to shift? So how to shift, guys? We'll just write ARR of I plus 1. Okay, ARR of I plus 1 equal to ARR of I. So in next location, store the current element. Store the current element. Store the current element in next location. Okay, right? Got this? So starting from here, all the element would be shifted towards right. Then I can happily store the new element, that is x at AR of 0. And yes, don't forget to increment the size of it. Okay, this is what we need to do when we are inserting at beginning, guys. Okay, right. And the next thing is insert at any position. Insert at any position. So how about that, guys? How would we exactly do? So let me clear out this thing. So is it understood, guys, this entire thing, this thing, in how we are doing insert at beginning, how we are inserting a new element at the beginning of the array? Okay, Sumit, you try to find it out. I think we have discussed enough question in time complexity that you can uh, realize what is the time complexity for this one. Okay, why decrement? Because I'm coming from right side. I value is okay. N value is let's say 5, right? I started from 4, so I have to come to 3 next time, then 2, then 1, then 0, right? So I have to decrement. N is the size, like what the total number of element in the array. Okay, n plus plus Pratik, after storing the element, obviously your size of the array got increased, right? You are now storing one more element, so you have to increase the size, increment the value of n. N is what? Total number of element in the array. So after storing a new element, obviously you have to increment the value of N, right? Now you are holding one more value. Got it, Pratik? Okay. So I hope it's now pretty much clear, this operation. So now if I talk about insert at any position, okay. Oh, Pratik, you did, okay, I didn't get your point. Someone has mentioned this thing. So are you asking basically what is this n plus plus? This is post increment, right? Increment operator. Yeah, okay. So this is nothing but n equal. So it will just increment the value of n by 1. That's all. Okay. It will just increment the value of n by 1. I didn't get your question. Sorry for that. So yeah. So let's say we have this array. Let's take some dummy values 7, 5, 3, 4, 9. Okay, now index 0, 1, 2, 3, 4, 5. Now I'm saying insert at any position. Okay, so I have this position. I'll mention, let's say I want to insert at position 3. Okay, um, this is let's say assume that position starts from 0, guys. You can also assume position first position, second position will start from 1, first position, second position, third position. That is up to you. But let's say we assume that position starts from 0. Okay, and I want to insert a new element, that is x. Some value is there. Let's say 8. I want to insert at position 3, maybe index 3. You can say I'll say position 3. Okay, if you are getting confused, let's not include this position starts from 0 and all. Just say position 3. So this is first position, this is second position, this is third position. So I want to insert the new element, that is 8, here at index 2. Position 3, so index 2. Okay. So in this case, what we need to do? So I have to make this place vacant. That means I need to shift all this stuff towards right by one step. Not all the element, I just need to shift all the element from this index 2 onward, right? So here what we will be doing, we will be coming like from I equal to n minus 1. Okay, I greater than equal to position minus 1, right? Why position minus 1? Because position is 3 and I need to shift all the element from index 2 onward. So position minus 1, I have to come up to this point, up to index 2. I minus minus. In earlier, when I had to insert at beginning, I had to come to 0, but now I just have to come till position minus 1. Okay, same thing. The code would be same. So you'll just store AR of I plus 1. Like sorry, you will store AR of I in AR of I plus 1. So copying the current element in the next location, right? So after that, you can easily store the new element at position minus 1. Why position minus 1? Again, same thing. Position given is 3, index is 2. Position 3 means index 2. So x you are storing at position minus 1. Just you have to be very careful with the question, guys. If in the question it has said assume that position starts from 0, so maybe you don't have to do this position minus 1 thing. And yes, after this also again you have to increment this n. So this is how you insert a new element at any position, at any given position, guys. If position would be given as 1, so this will become 1 minus 1, that is 0. So this entire operation would be same as the previous one, insert at beginning. Okay, right? When position is 3, so this is first position, second position, and third position. So index is 2. Okay, right? If in the question it has been said that assume position starts from 0, then you would do it differently. I think you in that case you don't have to write position minus 1. You can directly go with the position. Okay, so I hope it's clear. Understood this, right? Understood this, everyone? Just I'm looking at this chat, so just put your responses, guys. Is this operation, this whole insert operation clear? If it is clear, then I would need you to like do this delete for me. Okay, you maybe take that as an assignment. You do this delete thing. Okay, delete this beginning and okay, at any position. You take that as an assignment. Okay, again that would be shared with you. So you take that as an assignment, guys. This delete thing. One more thing I would like to give you as an assignment. Delete operation. Okay. Yeah. So let's say this is your array. Some values are there: 5, 7, 2, 3, 1, and 4. Maybe this 0, 1, 2, 3, 4, 5. So these are the 6 elements, right? You need to write the code to rotate this array k times. So k is a variable, so whose value would be taken by the user. Will take input. Let's say I'll take value of k as 3. So I need to rotate this array left k times. So if I rotate this array once, so what I'll get? So this 5 would come here. So I'll get 7, 2, 3, 1, 4, 5. This would be the content of the array after first rotation. After second rotation, you will get 2, 3, 1, 4, 5, 7. After third rotation, you will get 3, 2, sorry, not 2, 3, 1, 4, 5, 7, 2. So this should be your output. After kth rotation towards left, what is the array content? Print that. Okay, right? So you do this thing, guys, and yeah. So you would be basically doing this thing as an assignment. So it's time for one more quiz. So let's get to that. So Kriti, can we have that quiz right now?
Yeah, sure, sir.
Okay, thanks.
Alright.
Yeah, guys, the quiz link is on your screen and it would be shared in the chat shortly. So you can go there and submit your responses and let me know as soon as possible so that we can get into this linked list concept. Okay. Maurice, no, I think it must be different. Can you check it, Kriti? They're saying they got the same quiz.
Just a minute, sir.
Okay, sure.
Same quiz.
Can be on mute and just check it. Okay.
Yeah, yeah, sure, sir. I'm checking it.
Yeah, guys, don't worry. We're just checking it. Yeah, yeah. Just a moment. Give us a moment, guys. Don't spam the chat box. Just wait for a moment. We are just checking.
I'll remove this screen for a minute, sir.
Yeah, sure. Yeah, hold on a moment, guys. So you wrote this as a first quiz. Okay, might be some typing mistake with the link, typing mistake with the link. Sorry. So just wait for a moment. We would get it done. Okay. Meanwhile, while it is getting checked, yeah.
Uh,
Yes, please.
Sorry for the interruption. Can we have this quiz after 5 to 10 minutes, or you explain
Yeah. Sure.
them
Sure.
the
Sure.
topics?
Sure.
Sure,
Sure.
sir. Sure. Thank you so much, sir.
So guys, so it would take some time. So we decided we would carry on with our discussion of linked list, and the middle, maybe after some time we can get back to this question. Okay. So sorry for your inconvenience. Yeah. Hi, Vamsi. So let's go for this. Okay. Let me clear this thing out. Tarun, you got the correct quiz. Okay. Anyway, we would come to that again. Let's focus on here. Sorry, we'll be discussing this linked list thing. Linked list. Okay, guys. So, what is this linked list and all? I think we all know that linked list is nothing but there will be some values and which are linked together, like this, which are linked together. And this thing, the box-like thing which I have drawn, this is known as node. Like all these are nodes, right? So there would be several nodes which would be linked together. That is our linked list, right? So what is this node? So this node basically will have two parts. One is data part. One is the link part, or I would just call next, because this next basically is a pointer which will hold address of the next node, right? So this link thing is nothing but, guys, it is this pointer next which is holding address of the next node. That's all. So in data I can store some value, and in next I can hold some address, let's say 201. So maybe this node address is 101, so it is holding 201, so it is pointing to another node whose address is 201. So it would also have the data part and this next part. Okay, it might contain 20, and there might be no more node after this node, so this will contain null because there is no more node after this. So value of this next pointer of this node would be null. Okay, right. So let me also get into this stuff, how to create this node or what is this node. So you all know, right? Tell me, guys, how to like what exactly we use to create a node. Anyone? Anyone can say? Yeah, Emma, we are discussing about linked list, not regular discussion. Yeah, can anyone say me like how exactly we create this node? What we use? Yes, one. Yes, great. Structure, right? We use structure. So let me write this one for you. Struct struct node. So there would be this data part, and there would be this link part. So it is struct node star next. So there would be two members, right? One would be this data part, and one would be this pointer. So this pointer is nothing but it is a pointer to struct node, right? So this is a structure. Okay, fine. What is this structure called as? Can anyone answer? What is this structure called as? So we call this structure a specific name. There is a specific name for this kind of structure, right? What is this structure, guys? Can anyone say, yeah, this is a structure, fine. But also have a specific name for this kind of structure. What is this structure? Yeah, I'm just waiting for your responses, guys. User defined data type, it can be class also, structure. Okay, I'm just focus on this C thing or C++ thing, Z thing. Okay, and I have this node. So what is this thing? Yes, Vamsi, you're correct. It is self-referential structure, not differential, Jeffrey. You are getting into this maths differential calculus and all, not differential, referential. self-reference structure. Okay, why this is called a self-referential structure? Because this next, there is one member inside this structure which is actually pointing to the same kind of structure. So it is pointing to a self kind. That is why it is known as self-referential structure. Okay. Yeah. So how would we basically create a node? So obviously we have mentioned that to yeah, linked list, it is obviously it involves dynamic memory allocation. So we have to allocate memory dynamically, and for that we need to have a pointer. Okay, so we have to allocate memory for one node because I want to have this data part, next part. So if I want to create memory for one node, then I need to have a pointer of this node type, struct node type, right? Okay, so I will create one pointer first, struct node. Let's say head. What is this head pointer? Why I've taken this head? Initially, it may be null. Head pointer would point to the very first node of the linked list. Okay, head pointer would point to the very first node that we call as head node, guys. Okay, so every time you create this, every time you want to create pointer of this structure, pointer variable of the structure, you have to write every time this struct node, struct node, struct node. So if you don't want to write this struct node every time, what we can do is here we can use this type def. This is very useful, guys. This type def. So we can use type def. Type def is used to create alias. So type def, what it will do is it will create another name, an alias for this struct node, and I'll just name it node. Okay, so in place of struct node, I can now use only node. That would mean that struct node. So node is another name for struct node. It is like if I write type, yeah, type. Sorry, if I write type def int cat. So wherever in the program now, if you use cat x, this will mean actually integer. Okay, right? Yeah, Mavila, I think all this question, like all this thing are mentioned already in the community. Like how can you submit assignment and all. Maybe one of our team member would help you out in this chat section itself. Okay, they can guide you. So see, so this type def is nothing but it would just create an alias. Okay, it will create another name for this data type like this. Okay, so we don't want to use this struct, like we don't want to write this struct node every time. So I just want to write node. So that's why I created another name for this struct node as node. So I can write now node star head equal to null. Initially it would be null. There is no node at all, or linked list has not been created, you can say. Now I want to create one node. So how would we do it? It's very simple. You'll write head equal to, remember typecasting, right? I would now typecast into node star. Why? Because I want a memory for storing a struct node. Okay, I want this memory. Malloc, and yes, size of, let me clear out this part. I think this is not required anymore. Yeah, fine. Size of this node. So I need memory for one node. So this malloc will create basically a node which will have data part and this next part, and let's say address is 101, that would be sent to this head pointer. So head would contain 101, and we would say that head is pointing to the first node, right? Okay, if we want to store some value or data here, equal to 10. So 10 would be stored here. You know this, right? Through pointer variable, if you want to access structure member, we have to use this arrow operator. Okay, so head of data equal to 10, and then head of next. As there is no node after it right now, we can assign it null. So it would be null. Okay, so this is what we are doing. Why I mentioned this DMA thing is you need to be very clear, guys. This head is present in stack memory area because it is a local variable. It is a pointer variable. So it is created in stack. This node is actually located in heap memory area. So you need to remember that. Okay, you need to understand that. Got it? So head is a pointer which is in stack memory area, which is pointing to that node memory which is created in heap memory area. Okay, you got the basic idea, guys, how basically we are creating a node and we are storing data in the data part and like null in the next part. So this was like the basic first node creation. That's all. Clear this thing? Is it clear, guys? Okay, I want to take this thing forward. Like see, if you're doing linked list program, you have to create many nodes. So I'll not be doing this malloc thing every time. I don't want to write this pointer equal to whatever pointer equal to malloc, pointer malloc every in every interval. I don't want to write that. So what I will do is I will write a function. Okay, I'll write a function whose task would be to create a node. Okay, every time I need to create a new node, I'll be calling that function that would do the task. That is the whole purpose of function, right? So to make it modular, and also it would help us to reuse the code. So let's go for that one. Okay. Yes, that's possible, Varun. Yeah, that's possible. So let me clear this thing. Let's go to this create part actually, where I'll help you to understand this create thing. So the create function, create function goes as this: node star create. Okay, so it would take an argument, basically the data of the node. Okay, so here I will create a pointer, maybe new pointer, because I want to create new. So here itself I can allocate a memory. So I'll write node star malloc size of one node, right? Then I can write new of data. We have the data, right? X, and then new of next. We don't know what would be next now, so we can just assign null. And finally, we can return the address. So one node would be created. Okay, so new is holding, let's say address is 101, so new would contain 101, new is pointing to this, then x is being stored, let's say x data is 10, so 10 would be stored in this data part, null would be stored in this next part. Okay, now we need to return address of this node created. We have to return address of this node. So where is this address stored? In new pointer. So we would return new, value of new. Value of new is nothing but 101, which happens to be address of this node. Okay, this is the function definition of this create, guys. Whenever you require, let's say in main function, you are in main function. Now you want a node, new node. So what you will write? So you will just write node star nptr equal to create. Create. You may send this value, let's say 10 or 20, whatever, 20, let's say. So what it will do? So this create function will create a node with data 20 and here null, maybe address would be 401, and it would return that address to nptr. So nptr will be holding this value 401, this address basically, and we say nptr is pointing to it. Okay, now you can like move on with the operation where you have to put and all. Okay, got it? Understood this? Understood this thing or not? What this create the thing is. So every time we are not going to write this malloc every place after every interval of time. Whenever we require to create a new node, we'll be calling this create, right? So that would do its task, and we will have our node, and then we can do something about it. Okay, right? So yeah, so now if I talk about some operation, now if I talk about, let's say, insert at end operation. Okay, before that, I think the issue might have been resolved. So if the is that resolved now? Can we have that quiz now?
Yes, sir. We have checked. It is the same. I guess they need to refresh it. I'll share the screen. It's the same link.
Okay, okay, sure, sure. Yeah, guys, I guess you heard it. So just refresh your browser and attempt for the quiz. So we would again share the link, basically the same link.
Yeah.
Okay.
Maybe there's some confusion. They need to refresh
Yeah,
it or open in a new browser.
sure. So yeah, guys. So you heard it right. So just do accordingly. Yeah. So the link is in the quiz. Yeah, Mr. AK. Yeah. So am I not taking revision into a different direction? Like you're not able to understand things. I said east. Am I taking towards west? Yeah, yeah. Quiz thing. Time complexity would be there. Yes, Pratik. There would be some question regarding time complexity. Yes. Shivam, can you just reload it or something? Maybe. Yeah, I guess. Guys, you are getting the same thing till now. Just confirm. Give some confirmation. Yeah, Pratik, we are working on the same. Let's. Okay, so basically we'll continue this linked list discussion even in the next session. Along with that, we would also cover some more things. Okay. Yeah, Mr. AK, I would ask the same thing. Am I not taking your vision to another direction? So, direction, another direction. So, I will not take your like vision towards. I didn't say. I meant. I didn't mean that you. I'll take you out of this data structure and I'll put you somewhere else. So, you'll be there in data structure and algorithm. So, only thing is, I would try to the make you understand in a better way. Okay. First question, can you, Rajalakshmi, can you mention? I think the question was insert at beginning in array, insert at beginning. It was the question, right? Insert at beginning. So insert at beginning, we need to like sift all the elements, right? So we have to traverse through all the elements of the array in order to sift them, right? So that's how it takes.
Sorry to interrupt you, sir. I have
Yeah,
sent another link in the chat.
yeah.
Guys, can you check if that's working? From my side, it's working fine.
The need pin, a pin is being displayed, Sumit. It's on the video.
Yeah, it's the same pin. It's the same pin. Just the link is different.
Yeah, guys, so it has also been pinned, so you can click on that and get there.
Still same. Okay. I guess there is some confusion because
Yeah, but most of them I have also like I have got the actual quiz which we intended to show them.
yeah, yeah.
Okay, guys. So yeah, okay, it's not working for you. Fine. We would uh, leave that then if not working. So yeah, guys. So what I'm saying is we would continue this discussion of linked list in the next class again, like the insert operation and all. Insert thing, delete the delete thing will continue. Along with that, we'll also move on to other stuff also. Okay, right? So any doubt, any question you want to ask me for this session? Okay, you leave it. Okay, if you are getting the same quiz again and again, you can leave it, guys. Well, maybe there would be some issue. So you should also check by reloading it. But again, yeah, I'm asking if you are getting the same problem again and again, you may leave that thing. Yeah, any doubt, guys? Yeah, that would be given. Shubham, yes, that would be given. We have this thing, right? So we have this grow thing. Might know this. Okay, so I think on the first session itself, our director, Mr. Sai Kiran, had given you information about that. Okay, okay, so I think no doubt on this session. I think you understood everything, whatever we discussed. So we would continue our discussion in the next session. It's like we'll continue from the same point. Actually, we'll go on to discuss the insert and all. There again, we would create node and add them towards end or beginning, or we'll do some stuff there. Okay, we'll play with this pointers and this nodes by making this linked list thing. Okay, so okay then, guys. So I hope it's very. It was a nice session. Thank you for giving your time. Okay, thank you for basically thank you for bearing me for this long 1.5 hours. I would say. Okay, so let's meet in the next class with some new concept. Okay, so take care then. Bye.
Thank you, sir.
Yeah, thank you, Priti.
Thank you, sir. Guys, please don't forget to fill your attendance form. It's given in the chat. So you can fill your attendance form and we'll meet tomorrow at the same time at 6 o'clock. Thank you.